Good day, everyone. Welcome back to class. It's nice to be here once again today. And to everyone, I say welcome back. To all my returning subscribers, I say thank you very much. Your support has been keeping me going. Thank you for your support always. And if you are coming across this channel for the very first time, this is where we learn biochemistry in simple English. You're welcome. Please stick around, subscribe, and enjoy the ride with us. So in today's class, what we want to consider is amino acid, and we are linking it up with protein, so we can, it's safe to say that we want to look at amino acids and protein, but we are starting with amino acids on its own today. Generally in biochemistry, you will have heard a lot of talk about amino acid. We have like 20 common amino acids, and when you are hearing their names, you'll be like, hey, which one is this again? Keep calm, no wahala. Hey, don't worry, we are here to sort everything out together. First, what are amino acids? Amino acids are organic compounds that are made up of amino group, the carboxyl group, and the side chain. Now, the side chain is actually specific to each of these amino acids, and that is what makes them differ from each other. The side chain of each amino acid determine what amino acid we are actually dealing with. But basically, it is safe to say that we have five components that makes up the structure of a particular amino acid. The first one is the central alpha carbon, which is where all other components will be attached to. So this is usually at the center of the amino acid structure, followed by the amino group, which is the NH2, which is at the left side of your structure, followed by the carboxyl group, which is usually at the right side of your structure when you are drawing your amino acid structure. Now, followed by the hydrogen atom. Then, lastly, followed by the side chain, which is the R group. So, with that knowledge, let us try and sketch out a structure of general structure of an amino acid now. So, we said first we have the alpha carbon, which is at the center. This is our alpha carbon at the center. Now, we said it is being followed by the amino group, which is, I said it earlier, that is usually at the left side of your structure. So this left side now, we put our NH2, which is our amino group. So we are done with this. We are done with this. Now, to the right side of your structure, we have the carboxyl group. So we have the COOH, the carboxyl group. Now we are done with this. We are left with two. Now, followed by the hydrogen atom. So we can put that one here. We have hydrogen there. Now, followed by the side chain, which is the R group. So here we now have the R group. So this is just the general structure of any amino acid. So any amino acid that you see must have this particular, must look like this. The only thing that makes them differ from each other is now this side chain. So if I remove this R, let's say I'm removing this R now, I'm now replacing it with CH3. So definitely this structure now is the structure of alanine, which is an example of an amino acid. I hope you understand that. So whatever thing you want to be changing will only be at this R side chain. I hope you understand. I'm taking time to explain this so that this will help you to be able to understand different structures of your amino acid. With this now, knowing the different structures of your amino acid will not look so cumbersome to you, and it will help. Just know that this is the general structure of this amino acid. Now, the only thing that would be different there is the changing of these side chain. which gives each amino acid their name. We have different types of amino acid. We have different types, but the most common one that we usually talk about so much more in biochemistry is like the 20 amino acid. But we have more than 20. We have them in hundreds. Now, let's move on to the classification of this amino acid. Amino acid are basically classified into five groups. Number one, we have the non-polar amino acids. They can also be called hydrophobic. Hydrophobic, meaning that they hate water. Let's as the name implies, this hydro is also water. So we have water here, and this phobic, fear. When they say, somebody has a fear of heights, some people has fear of water, some people has fear of insects. So but these amino acid, they have fear of water. That is why we name them hydrophobic. So, and they are also non-polar. Example of amino acid in this category include alanine, valine, glycine, leucine, proline, isoleucine. Now, let's move on. The polar amino acids are also referred to as the hydrophilic. Remember, the non-polar are hydrophobic, but these polar one are hydrophilic, meaning that hydro water, philic loving, they love water. So example include, we have the serine, cysteine, truline, ethicene. The third classification is the basic amino acid. The third classification are the basic amino acid, meaning that they are basic in nature. They are basic. Remember your acid and base. So this particular amino acid are basic in nature. So the example include lysine and arginine. The fourth classification is acidic amino acid. They are acidic in nature. Example include glutamate and aspartate. Now, the last one is the aromatic amino acid, meaning that they in the side chain they have a ring shape. In that, remember your basic CHL. So we have the aromatic amino acids. So example include phenylalanine, tryptophan, ethicene. In amino acid, when you want to write out the name of your amino acid, most of the time you will see that, let's check something together. Here I wrote glutamate, I wrote out aspartate, I wrote out alanine here. But when I came here, see this place, ALA, which also means alanine. So that when you are writing out your amino acid, there is no need in writing full names of the amino acid. There are basic short names that have been assigned to each amino acid, and mostly is even the first three letters of this amino acid, although we have some that the basic three letters that were given to them are not the first letters of their amino acids, of their real name. But basically, mostly most of amino acids, when you have the short form, their short name are basically first three letters of their name. So alanine, which is this, we have ALA. Valine, so we are using the first letter, the first three letters. I hope you understand that. So now let's move on. The next one we want to consider is the classification of these amino acids based on their essentiality. Let me do a quick recap of where we started this class today. We started with amino acids, stating that amino acids are organic compounds that are made up of the alpha carbon, which is the central carbon. They are made up of the amino group, which is the NH2, the carboxyl group, which is the COOH, the hydrogen atom, and the side chain, which is the R group. And I said that what makes amino acid A different from amino acid B is what is at that side chain. So with that idea, we're able to draw the structure of a basic general structure of all any amino acid, which means that the only thing that will be different is the R group acid. From there we went to the classification of amino acid, where we made their classification based on their nature, and that we made 5 classification. The first one is the non-polar amino acid, also known as the hydrophobic amino acid. The second one are the polar amino acids, which also known as the hydrophilic amino acid. The third one are the basic amino acid. The fourth one acidic amino acid, while the fifth one is the aromatic amino acid. Moving on now, we want to now classify these same amino acid based on their essentiality. The first one, we have essential amino acid. What do we mean by essential amino acid? These amino acids are basically not something that our body can produce. So we have to get them from outside of our body. So exogenous sources, such as our diet, we need to get this amino acid so that the body will use it to be able to function properly. And example include the phenylalanine, the methionine, the leucine, etc. We still have more, etc. So now the non-essential amino acids, these ones are the amino acids that our body can produce on their own, they can make on their own. There is no point in us sourcing for them outside again. So our body can easily give them to us. Which example includes the glutamate. Example also includes the alanine. We've come to the end of today's class. See you in the next class. Bye bye.